All right, if you're an AI developer, this probably sounds familiar. You build an amazing demo with one giant, super clever prompt. And it works, kind of. But the second you try to push it to production, the whole thing just falls apart. It's inconsistent, it's unpredictable, and it's a nightmare to automate. You know what? That is a classic trap. The solution isn't just a better prompt, it's a totally different prompting architecture. So let's dive into how the pros do it with prompt serialization.
So here's what we're going to cover in this explainer. First, we'll talk about that jump from demo to production. Then we'll compare plain versus structured prompts, break down the serialization hierarchy, check out some real-world agents, and then we'll even get our hands dirty with some code and interview prep. And finally, we'll wrap it all up with the key mindset you need to build truly production-ready AI.
Okay, let's get right to the heart of the problem. That journey from a slip demo to a bulletproof production system, that's where so many AI projects just die. That one big prompt that felt so clever on your laptop, it becomes your biggest liability the moment it hits the real world, with all its chaos and the need for rock-solid automation.
I love this quote because it just hits the nail on the head. We're not just talking about a coding trick here. Using a structured format like JSON is a fundamental shift in how you think. You're moving from just hoping the AI understands you to knowing it will. And let's be honest, in a production environment, hoping doesn't really cut it.
And this slide lays it out perfectly. A demo is all about impressing people. A production system is about performing, day in and day out, at scale. A plain text prompt gives the AI way too much room to be creative, which leads to random outputs that will absolutely break your pipelines. Production demands predictability, and that means you need structure.
So this brings us to the core concept, prompt serialization. Think of it as the engineering discipline behind professional prompting. It's not about writing a beautiful, long paragraph. It's about organizing your instructions into really specific roles, rules, and constraints so the AI has zero ambiguity. This is how you build agents you can actually trust.
All right, so let's put these two approaches head to head. This is where you'll really start to see the huge advantages of thinking like an architect. We're not just tweaking words here. We are fundamentally changing how we communicate with the language model. This table really breaks it all down, doesn't it? A plain prompt is basically one instruction. You have very little control, and the format is going to be all over the place. Fine for a quick demo. A structured prompt, on the other hand, uses multiple layered messages. This gives you tons of control, which means you get predictable, stable output. That's a non-negotiable for production systems.
And hey, don't just take my word for it. This is where all the serious research is headed. Take a look at frameworks like Braid. It literally throws out natural language chain of thought and replaces it with structured, machine-readable graphs. And why would they do that? Because it massively boosts accuracy and efficiency. The whole field is moving from vague text to logical structures for any kind of complex reasoning.
So you're probably asking, okay, how do I actually do this? Well, the most powerful way is through a really clear hierarchy of instructions. It usually breaks down into 3 specific rules. Once you get this hierarchy, you unlock a whole new level of precision and control over your AI.
And here it is. It's basically a 3-step ladder of importance. At the very top, you have the system message. This sets the absolute rules. Then you have the user message, which is the specific task. And finally, the assistant message, which gives context or examples. The AI processes them in this exact order, with the system message acting like the ultimate law of the land.
Let's start with the most important one, the system role. Think of this as the AI's core operating system. Before the model even sees what the user wants, you've already defined its entire personality, like you are a strict interviewer, and its non-negotiable rules, like you will not provide answers. This is your #1 tool for safety and control. Next up is the user rule, which is way more straightforward. This is simply the to-do list. It's the specific question or the command you need the AI to carry out, like generate 5 interview questions about agentic AI. And of course, it has to follow all the rules we already set in the system message.
And finally, we have the assistant role. Now this one's pretty clever. On the surface, it's just the AI's side of the conversation. But the real power move is to use it to inject few-shot examples. You can basically show the AI, here's a good question, and here's a good answer, to steer it towards the exact format you need.
Okay, enough with the theory. How does this actually play out with real production-level AI agents? Let's check out a couple of classic examples where this whole serialization thing isn't just a nice-to-have, it's completely critical. First up,
A customer support bot. The last thing you want is your bot giving out wrong pricing information or bad legal advice, so you lock it down with a super strict system rule. If a user asks about anything other than shipping, that system rule takes over and shuts it down. It creates a powerful safety guardrail.
Now for automation. This is where things get really exciting. If you're trying to pull structured data out of messy text to put into a database, you need perfect JSON. Every single time. No exceptions. Here, you use the system role to define the exact output schema down to the last detail. This is how companies are getting over 90% valid JSON, which makes real automation finally possible.
And this idea scales up to some incredibly complex systems. Frameworks like Strodot aren't just using one prompt. They use an entire structured pipeline. First, the AI creates a plan based on a data schema. Then it generates code to execute that plan, and a feedback loop catches and corrects errors. Every step is guided by structured prompts. You're treating the LLM like an engine in a much larger, more reliable machine.
All right, time to make this super concrete. We'll look at the actual Python code you'd write, and then we'll run through some system design questions you are very likely to get in a serious AI engineering interview. Questions that really test if you get it, like what's the difference between a RAG system and an AI agent, or how do you handle memory in agent architectures?
Okay, take a look at this code for the OpenAI API. It's actually beautifully simple. See that messages array? That's it. That is prompt serialization in action. You've got one dictionary for the system role, laying down the law, and another for the user role, giving the specific task. This is exactly how you engineer control right into your code.
Now, imagine you're in an interview and they drop this question on you. Your answer is going to tell them everything. It shows whether you're still thinking about single prompts or if you can think like an architect and design robust, scalable systems. This is really a test of your understanding of agentic architecture.
So a rock-solid answer would break the problem down into its core components. You talk about having a planner agent to figure out the steps, a tool executor to call APIs, a memory store for context, and a vector database for retrieval. Then, to really seal the deal, you'd mention an orchestration framework like LangGraph to tie it all together. That shows you think in systems. And if they ask about reducing hallucinations, you're ready to talk about RAG, structured prompts for validation, and feedback loops.
All right, let's bring this all home. Getting on board with prompt serialization is so much more than just a new technique. It's a fundamental shift in your mindset. It's about moving from being a prompter to being an AI engineer. So why does this matter so much? It all comes down to control. It gives you predictable, stable outputs, which is the only way to build reliable automation. This is the absolute foundation you need to build real, valuable AI agents that you can actually trust to run on their own without you having to constantly babysit.
And this is the question I really want to leave you with. The next time you start a project, ask yourself this. Are you building a fragile demo that only works when the sun is shining? Or are you architecting a robust system that's ready for the real world? That first choice you make, plain prompt versus structured prompt, is going to determine everything.
If you're serious about learning how real-world AI systems and these complex agent architectures are actually put together, make sure you subscribe to Naveen Tech Hub. We're always breaking down the practical, hands-on engineering concepts you really need to know.
Thanks so much for watching.